All right, today we're diving into something that feels like a genuine step change in artificial intelligence. We're talking about moving beyond AI that just predicts the next word to an AI that can actually, well, reason. Let's get into how this new way of thinking really works. So just look at this number for a second, 84.6%. On its own, it's just a number. But what if I told you that single figure represents a massive, monumental leap forward for AI? We're about to unpack what it means, and trust me, it's a bigger game changer than you might think.
I mean, think about it. What if an AI could be thrown a super complex logic puzzle, something it's never ever seen before, and just solve it? That's the core challenge, the wall that developers have been slamming into for years, and it's exactly what this new tech is designed to smash through.
But, to really appreciate the solution, you've got to understand the problem. So first, we have to talk about AI's big logic problem.
Okay, so almost every AI you've ever used runs on what experts call System 1 thinking. It's incredibly fast, it feels intuitive, and it is a master at matching patterns. It's basically a super sophisticated prediction machine. But here's the catch. It's not really reasoning. It's making an incredibly educated guess, which is why AI sometimes gives you answers that sound totally right, but are completely made up. You've heard the term, hallucinations.
And this isn't just some funny quirk. For a developer, it means getting back buggy code. For a scientist, it could be a math proof that looks flawless but is just wrong. The bottom line is, if the answer isn't somewhere in its massive training data, this kind of AI just plain gets stuck.
And this is where Google's Gemini 3.1 DeepThink just completely flips the script. We're not talking about a small upgrade here. This is a fundamentally new architecture. It's a whole new way for an AI to think. This slide really says it all. We're moving from that fast, instant guesswork of System 1 to the slow, deliberate, methodical problem-solving of System 2. Instead of just matching patterns, DeepThink actually uses logical reasoning. It checks its work, it verifies its steps with evidence, and then it gives an answer. And look, this shift didn't just happen out of the blue. By the middle of 2024, it was clear that the old models were hitting a ceiling. So the whole industry started moving towards giving models more hidden computing power. You can literally think of it as thinking tokens to chew on hard problems. This all led to Google's big announcements in February 2026. First for researchers, and then boom, just a week later, it was live in the API for developers. Which brings us right back to our magic number. The ARC AGI-2 benchmark is specifically designed to test an AI on logical problems it's never seen. The best models before this, they struggled to even get to 40%. Gemini 3.1 DeepThink, 84.6%. I mean, just look at that difference. That is the leap we are talking about. So the big question is, how? How in the world does it actually pull that off? Let's get into the nitty-gritty of how DeepThink works under the hood. The secret sauce is this concept called test time compute. The easiest way to picture it is like giving the AI a hidden scratch pad. Before it even thinks about giving you an answer, it uses this private space to map out its thoughts, test different ideas, and basically check its own work. Now, for all the developers watching, this is where it gets really practical. Google put all this power into one API with a simple 3-tier slider. This is smart because you don't need to pay for all that brain power if you're just asking a simple question. You can keep it on low or medium. But for those really tough problems, you crank it up to high, and that kicks in the DeepThink mini engine for maximum reasoning power. But here's where it gets truly wild. It's not just thinking harder inside a black box. DeepThink uses what they call an agentic workflow. It comes up with a plan, then it literally pauses itself to go write and run some code, or search the web to check a fact. Then it looks at the results, corrects its own thinking, and only then does it give you the final answer. It's actively testing its own ideas against the real world. Incredible. So, okay, it crushes academic tests, we get it, but what does this mean in the real world? What can it do for actual businesses and engineers beyond the benchmarks? And that is a totally fair question. It's a common critique you see online, right? People wonder, is this kind of power only useful for solving some obscure math problem? Is it actually practical for the messy problems we deal with every day? Well, the answer is a resounding yes. It's already being used to untangle these massive, ancient code bases that would take a human engineer weeks to figure out.
It's optimizing incredibly complex global supply chains. In pharma, it's finding signals in noisy, messy lab data. It can even reason about pictures like complex engineering blueprints.
Of course, there's no free lunch. This kind of power has a trade-off. Using that high setting costs more. You're billed for those thinking tokens. And it is way, way slower. A single, really hard question could take up to 8 minutes to get an answer. So for developers, the real skill is knowing when to unleash the beast and when to stick with the faster, cheaper options.
So where does this all go? This isn't just about a more powerful tool for today. This is a building block. It's a stepping stone to the next real frontier in AI. And one of the most exciting future-facing features is something they call thought signatures. Basically, it lets the AI save its line of reasoning and its context and then pick it right back up in a new conversation. It doesn't have to start over from scratch every single time. And that is the absolute key. Thought signatures are the foundation for building true AI agents. The kind of agents you can give a single complex goal to, and it can just go work on it autonomously for hours, maybe even days, without ever losing its train of thought.
So this leaves us with one final, pretty mind-blowing question to think about. We're now at the point where AI can truly reason. Once we make that reasoning fully autonomous, letting an AI just chip away at a hard problem for days on end, what are the big, seemingly impossible challenges that we're finally going to solve?